This chapter one will be divided into two sections in it. Today and next Tuesday we'll finalize this chapter one. It's all about basic concepts. At the same time, I'll try to explain on the paper here exactly. I'm trying to do right things, and you can get this through as a recorded video in Blackboard, inshallah. The outline for this presentation, I'm going to introduce this electric circuits in general, talk about systems of units to be used, and after that talk about electric charge, define the electric charge and current, define the voltage, do some exercises for those three basic components in the electric charge, current, and voltage. So this will be for today. For next session on Tuesday, we'll continue on defining what is the power, energy, and circuit elements, and do exercise at the same time. By covering all these subjects, we can finalize this chapter number one as all. Okay. As introduction, what is electric circuit in general? Electric circuit is interconnection of electric elements. We mean by this, if you have like resistors, capacitors, inductors, combination of these, and we have what you call, active, passive, and active elements. And passive, we have three elements in the passive. We have resistor, inductor, capacitor. And active, we have different type in the semiconductors. We have like op-amp, operational, amplifier. We have diodes. We have transistors. For us, for this lecture, circuits one will be concentrated first of all about using the resistors, inductor, and the capacitor, and the passive elements as well. Okay. Now, for the course objective for all this semester, we're going to analyze circuits. This is the objective: to analyze circuits by using different laws like Kirchhoff law, and mesh analysis, nodal analysis. Those are and other type of analysis will be defined later on during this semester. So the objective is to analyze the circuit, not to design, but analyze the circuit by using mathematical equations and analyze those circuits. And at the same time, by analyzing this, you can study the behavior of the circuit itself. Now, how our circuit will behave once we're supplied by certain input. Can be like step like this, can be DC voltage like a battery, for example, can be AC voltage, can be ramp, can be sawtooth, inputs, and so on. So we need to study the behavior of the circuit itself, why we are supplying it by different type of inputs. And also we need to check the how those elements, especially R, L, and C, how they interact with each other. I think especially once we reach the last topics, where we have R and L together, series or parallel, when we have like R, L, and C. Okay, once you supply them, how L and C they fight each other and it dominates the circuit. So those are the things that we need to analyze and understand during this semester. Okay, the first thing to understand here is the system of units to be used. And what is that system of units? The system of units is what you call international standard language for measurement, of course. So this is why we call it standard, because it's understandable by all engineers, different fields, civil, chemical, electrical, mechanical engineers, and all type of engineers. They understand those. They have to use this system of units to understand the measurement of the measured physical parts. Okay. Uh, the international system used is the SI system, international. They call it metric system. We have 7 principal units, okay, which are those units here, and we combine them to get some physical quantities, for example, to derive physical quantities. First of all, in those 7 principal units are mass. Its unit, it's kilogram, kg, as abbreviation. Length, meter, and time can be measured in seconds. Temperature in Kelvin, and amount of substance for any material will be in mole. Electric current will be in ampere, and luminosity intensity will be in candela. Just as example, now to combine by combining these and create some physical quantities, like for example, if you have speed, so speed is a combination between length and the time, okay, which is like meter per second. If you drive your car, will be kilometer per hour, for example. Okay, so we combine this, sorry, this one and this one, okay, to define the unit of speed as a physical quantity. We have also, for example, electric charge, which is a Q. So Q would be like ampere second. So we have this unit with the time. So will give us ampere second, which is coulomb. Coulomb. So this is today's want to be this study today. And we have so on. We have different quantities. So this is I'm giving you those two here just to let you know what we mean by physical quantity. So physical quantity is a combination of those 7 basic ones, principal units, okay, to define that quantity. System units, as all, okay, use the prefix based on a power of 10, for example, related to a large, to relate larger or smaller units. Example, if we take like a kilogram, which is 10 to the power of 3 grams, okay, and so on, okay. Kilometer, or let's say a mega or kilobyte, for example, you use it to that. So gigabyte, so gigabyte, which is 10 to the power of 6 bytes, okay. So those are some prefixes to be used, and you have their names here. Usually we're going to use and you're going to hear about tera, for example, giga, mega, kilo, okay, and milli, for example, micro, nano, okay, pico, for example. Those are the main things that you can hear this during this semester. Millifarad, for example, milliamp, micro Henry, for example, nanoamp, nanovolt, picoamp, something like this. Okay, so those are things that you have to be used to. Cannot tell you memorize, but while you are using them, you can understand them, you can memorize them by using them more, kilo and mega and so on, those prefixes. Now let's talk about charges or charge or electric charge and the current. As I told you, if you don't have any questions, I'll continue talking and explaining my slides here. So electric charge, what is electric charge? It's the basic quantity for electric circuit, okay? And electric charge is the amount of energy or electrons, especially those electrons that passes from one body to another one. Okay, you can charge yourself if you are used, for example, to during the summer, if you push your shopping cart and you touch your body, you touch somebody else, you discharge yourself on him or on her, okay, on anyone next to you. So this is what you call a transfer of electrons from you to another place, to another person. Now, the charges, the symbol of the charge or electric charge is a Q here. Can be small q or capital Q. I mean by a lowercase or capital Q like this, as symbol for the charge. Its unit is Coulomb C. That's the unit of that. So please, once you do your exercise, and I mark hard on that, I grade hard on that. If you give any number, any quantity, you have to mention the unit. Can be millicoulomb, can be coulomb, can be microcoulomb. You have to mention the unit, please, in your assignments or quiz or a final or midterm exam. So the type of electric charges they can be positive, and we call them electrons, and they can be negative, and we call them protons. Both of these electrons and the protons, they have the same magnitude. The only difference is the sign. So both of them, they have 1.602 times 10 to the power of minus 19 Coulomb. So this is the magnitude of one electron or one proton. Sorry. Okay, so keep in mind this. That's the magnitude of that, and the only difference is the sign, the plus for this one and the minus for the other one. Okay, the nature of the electric charges.
Doctor?
Yes, sir.
Plus for the proton and negative for the electron, yes?
Yeah. Sorry, yeah. Plus, yeah, I have to reverse this. Minus and plus here. Now, for the two basic natures for the electric charge are if they are same, if they are positive, they will, or negative, they will repel each other. They will push each other. Okay, if they have different signs, so electrons and protons, they attract themselves. Okay, if they have different signs, they will be like a magnetic field. If you have a magnet, if it's north and north, they will push each other, or south and south, they will push each other, and you call that one and repel each other. Or if they have the different signs, unlike charges, different signs, they will attract each other. They will try to be closer to each other. So those are the basic natures for those electric charges here. Okay, now if you have the same amount of electrons and protons, okay, same plus and same minus in terms of quantity, we will create what we call atom neutrally charged. There's no charge in that atom. Okay, atom is a combination of proton and electrons. So this atom will be neutral. Okay, and nothing will be stack, will be static, not movable, and this what we call neutrally charged if they have the same amount of electrons and protons. Any questions here?
Everything clear.
Okay, now we'll continue now to define the current itself. So we have the next two things to be done quickly, defining the current and the voltage. So the flow of this electric charge, this is what we call current, okay? And this current, while we are transferring electric charges from one place to another one, we create what we call current. Keep in mind, and this what will be explained later on here. Okay, let's talk about this later on. Let's continue on that third part here, or second part. Electric charge can be transferred from one place to another one to create the current I. This electric charge will create will convert energy from one type to another type. Yes, sir.
Doctor, for the definition of current, it should be in a closed circuit, right? the flow of electric charge in a closed circuit.
Yeah, of course, yeah. This will be explained on the circuit itself next time, okay?
Okay.
If you have a battery, of course. So this battery will create electrons and protons, okay? One going one side, the other one another direction. But they will be there unless if we connect, like if we close the circuit, we connect any type of load. At that time, we can create closed loop, closed circuit, and we can have current circulating in that circuit. This will be explained in details next time once we start talking about the circuits. Now, as I told you, this the movement of this electric charges will create will convert energy from one type to another one. Example: if you have in electric car, in a car itself, the engine itself, okay, to move, to rotate this engine, that's the rotor here, and this is the stator. We have to supply the stator by, let's say, for example, we have a DC motor. If we supply this one, we'll move electrons through this stator of that one. The current going in wire inside in that stator will create a magnetic field. That magnetic field will rotate the rotor itself. So by doing this, we're converting electric energy to mechanical energy. Okay, so by rotating this rotor here, we can move a fan, we can move tires, for example, for the electric for the car. So that's one type of one example of converting energy from one type to another type. Electric current is created when electrons move in opposite direction. Okay, than the proton. So if you remember, the proton are the positive ones and the electrons, they are negative ones. Okay. If you remember, if you have a positive charges and which are protons, if they are going this direction, that's a section of wire. If they are going this direction, so the current is following the same direction as a proton. If the current is going this direction, automatically those electrons, the negative ones, they are going the other direction, opposite of the current and opposite of this of the protons. So this is what I mean to I wanted to explain by this part here. Okay, current flows in the same direction as a proton, and opposite. I explained that. Electric current has a unit which is ampere. If you allow me, you can give me another 5 to 10 minutes if you don't mind, so I can explain the next slides. The relation between the current and the charge is basically this. This is the main equation, and you have to memorize it. You have to understand it also. The current is a derivative of charges during a time, okay, certain time. From this equation, we can also calculate the if we know the amount of the current, we can find the amount of the charges transferred between this time and that time for initial time to final time. Okay, before to do one exercise, I need just to define what is a direct and alternate currents. Okay, direct, if the current doesn't change, it's constant, like a battery, for example. So this is what you call direct and DC current, and this is our. Now we're going to use this all the time for our during our semester. The alternating current, if we supply our circuit with alternating voltage like this, so it's going a positive sequence, negative sequence, and so on. Okay, like that. So this is alternating current. Let's do one exercise. For example, here, if we need, if we're asked to calculate the amount of charges, okay, represented by 4 million proton, you remember. Okay, that okay, and just to be sure, one thing. You remember that one you know, yeah, this is another exercise. So one point, you know, each proton represents 1.602. If you remember that number, this is the magnitude of the you know, the proton or electron, minus 19. Okay, column per each you know, one amount.
Doctor, I think it's minus 23 maybe.
For the proton, yeah, minus. Okay, now
Minus, I mean to the power minus 23.
no, it's minus 19, right? That's the
could you explain more, Doctor?
Oh, okay. Sorry.
that's the magnitude, you know, for this, and since it's proton, so it's minus, all right? No, it's plus,
Doctor should be positive.
positive,
Proton.
and we multiply this by 4 million, which is 10 to the power of 6. So if you have any calculator, you can calculate this with me. 1.602.
It is 6.408.
Yeah. So it's going to be plus 6.408
4
10
times
to the
10 to the
power
power negative 13
column. Yeah. Okay. So that's you know, the amount of charges that are represented by 4 million protons. If there were 4 million electrons, it will be negative here with the same magnitude here, same amount of columns. Do you have any questions here for that one? Okay, now for the next exercise, we need to calculate the total charge entering a terminal of you know, any element, can be resistor or any load. So the total of charge, electric charges entering a terminal of that element is that amount here. Q equals 10 minus 10 to the 10 times or exponential minus 2t milli coulomb. We have to find the current at this time here. So you remember the equation, which is the current is the derivative of a Q, you know, to the time. If we take this this equation, will be 10 and minus 10 exponential minus 2t milli coulomb, of course. So okay, so this will give us what? The derivative of constants will be 0, right? So we'll end up with this. We'll end up with
20.
this, yeah, with this part here. So it's going to be minus with this minus here. So it's going to be 20, which is
20 e power negative 2.
Yeah, 2 times 10. That's 20 comes from 2 times 10. Okay, exponential of the same thing minus 2t. So at, let's say here, now we can calculate it, the I at 0.5 second will be 20 exponential minus 2 times 0.5, and this will give us the amount of 7.3536. I did this exercise, that's why I'm looking at the number. Milliamp, please, because it's milli coulomb here. So it's going to be milliamp. That's why, please, in your exercise, you have to be careful and you have to mention this one, because if you don't mention that unit, it's going to be half mark, okay, not the full mark for you. You should absolutely, because there's a difference between amp and milliamp. Okay, now the last 2 slides in we have another exercise to be done here. Okay, now the current flowing through element, and you have two two parts of this current. You have to calculate the charge entering that element from T0 to T equal 2. I'll give you the answer very quickly here. So the Q, remember I, which is derivative of Q divided by differential of time, or d time, dt. So Q will be the integral of this current throughout this time here, from initial time to the final time here. Okay, for our case, it's going to be like integral of the current, which is the first one, 2 amps, between 0 and 1, plus the integral of the other part, which is it should be 2. Sorry, back here.
1 to 2.
1 to let's say, because I need to physics and more explanation of that, but the final time, because it can be infinity, can be any number. So of 2t squared dt.
Doctor, it is specified in the question itself.
But the question specifies the number here. Okay, so this that's the final time. So here should be 2 seconds. This part, 2 seconds. So if you derive this, if you make integration of that one, you'll end up with here for the first one will be 2t. This is a constant here between 0 and 1, plus, and here it's going to be 2 over 2. Let's say, just to be sure, you have to be familiar with the integration derivation.
Yeah.
Okay.
2 over
So
3
2
power.
Just to explain, this is T3 over 3. Okay. Okay, and between 1 and 2. Okay, so if you do this calculation, so 2 times 1, which is 2, minus 0, which is 2 times 0, and the plus, that's the first part. The second part will be 2/3 of 8, right? 2 cubic 2 will be 8, minus 2/3 of 1, which is 1 to the power of 3, which is 1. So if you do this, this is 2 plus, here would be like 16 minus 2, that's 14, right? Over 3. Am I right?
16 over 3.
No, 14.
That's 16,
right.
but minus 2 here. 16 okay, minus 2, 14 over 3.
Final answer will be 2.518. One answer.
The final answer should be 6 point something, right?
6.6, but in a fraction it is 20 over 3.
Yeah, coulomb. Is that okay? Is that correct?
Yes.
Yeah. So this is how we can calculate, if you have you have like the current is changing during the time. Okay, look here, it was constant, and after that it was like with the ramp, but exponential one, t squared. This is exponential curve. So we'll end up with this exercise with that number of columns. Okay, voltage. The voltage, to move those electrons, we need a work or energy to be exercised to move those electrons from one terminal to another terminal. It's like a flow, water flow. Water flow. If you need water to flow from one part to another part, you should have like certain height, and you have water coming,
Doctor?
Flowing like this. Yes, sir.
I think we run out of time, and we have another lectures.
What time? 12?
Yeah.
Okay. Look, I have only this. Talk about this in a few seconds, and do last exercise here together, and that's it. Okay, if you allow me that,
Okay.
please. Is that okay? Can I continue? Okay.
Is it recorded?
Yeah, it's recorded. You can leave if you like. Just be sure that you registered yourself as a present in this lecture. Okay, the movement is performed by external electromotive force, and we call it EMF. And this is what we call voltage, that EMF. Okay, it's a differential of potentials, plus and minus, for example. If you have plus and plus, there is nothing will move. There is no, it's like a flat ground. So the water will not, you have to push it. So you have to create another potential to push that water, for example, to move from one side to another side. So the voltage between two terminals is the energy or the work needed to move a charge between those two terminals. Okay, and that's the equation that mathematically defines this this sentence here. Voltage is a derivative of the work, the energy, by the charge itself, and the unit of the volt is V. Let's go to the exercise. We can understand more. We have this exercise here to be done. So we have to move charge from charge Q from one point to another point, which requires like minus 30 joule to do this movement. We have to find the voltage drop, okay, across that element, any type of element. So we're given like if it's 2 column, for example, that charge, or if it's a -6 column. Let's answer the first one. Remember that V equals dW over or derivative of this energy by differential of this column, those charges, and this will be it's given already here. That's the energy required or the work required to move that those charges from terminal to another terminal, okay, by 2 columns. This is the columns needed to do that. If we do this, we'll end up with the -15 volts. Okay, if we do the other parts here, it will be same -30 joule divided by negative 6 columns, and it will be 5 volts as a final answer. So those are basic introductions to electric charges, currents, and voltages, and how we can play with them to find those elements. I'll stop it here, and we'll continue next session, next Tuesday, inshallah. I'm talking about the power and energy, and electric elements also, to finalize this chapter.
Doctor?
I urge you please to do more exercises on this. So,
Doctor?
yes, sir.
If they give us a function of energy in respect to a charge, do we derive it to get the voltage drop?
Yeah, of course, yes.
Yes, same as the exercise above, right? The one that we did for the current or the charge, I think.
Yeah, something like that. You have, if it's constant like this, you take it directly. If it's a function, you have to use it, and we'll give you how to find that final answer. It should be constant by the end. So here we'll end up by constant divided by constant.
Okay, thank you, Doctor.
With different units. So a volt, which is all the time, it's a joule by coulomb. That's a volt. That's the unit of the volt. Thank you for attending my first session, and we'll work all together during the whole semester to have, to understand this course and have good grades by the end of the semester, inshallah.
Doctor, can you upload this PDF and
the video? I will upload it right now, right away. Now, as soon as I
also the PDF
of this slide. Okay, yes.
Yes, thank you.
You're welcome.
Thank you very much.
Okay, okay. See you next session, inshallah. Assalamu alaikum.